In the first part of this video on exceptions, we will explain why exceptions were included in newer languages like Java. Then we will describe the syntax of a try-catch statement that is used to catch exceptions and illustrate catching predefined exceptions with an example, and conclude with an explanation of the difference between checked and unchecked exceptions. We begin by explaining what an exception is and why newer languages have included syntax to support them. An exception is an unexpected or error condition. Such events certainly occur within programs, whether they are written in a language that provides exception syntax or not. Having exception syntax in a language minimizes the clutter of error handling code that is present in programs written in languages that do not explicitly support exceptions. The reason is that in programs written in languages without it, it becomes necessary to return an error code from any method that can potentially cause an error. The method that calls it must then check whether it returned an error. If it returned an error and the calling method cannot recover from the error, it too must return an error code to its caller. It is not unusual that the point where an error can be recovered is many method calls away from where it occurred. So all the intervening methods must be involved in handing back the error information. Explicit exception syntax eliminates the code in all of the intervening methods due to what is referred to as automatic exception propagation. Exception propagation searches the chain of calling methods to find the method that can handle the exception, which eliminates the need for the programmer to explicitly write such code. If an exception is never caught, propagation will go all the way back to the main method, and the program will terminate, showing a stack trace of the exception propagation. Ada was one of the first programming languages to include explicit syntax for exceptions. It was designed for embedded systems. An example of an embedded system is software that controls aircraft or spacecraft. In such systems, graceful recovery from error conditions was critical. To simply display a message like "System error, please reboot" would be an unacceptable alternative in such a system. Including exceptions in a programming language requires adding some new syntax. We begin with the syntax that is required for handling or catching exceptions. The statement included in Java for that purpose is the try-catch statement. This syntax is a slight simplification of the actual syntax. Here we show a try block followed by one catch block. The try block contains the code that has the potential to throw an exception. The catch block contains that code that will be executed if a specific exception is thrown in the corresponding try block. The exception type specified actually encompasses exceptions of that class together with any of its subclasses. Every try-catch statement must have at least one catch block, but can actually have any number of them. Now let's consider an example that illustrates how to recover from one of the most common errors, which is when we ask the user to enter a numeric value and non-numeric characters are entered instead. In this program, we read in integers from the keyboard until the user enters a 0, accumulate the sum of those integers, and then display the sum. This loop is a sentinel controlled loop. 0 is the sentinel value that is entered to signal the end of input. Notice that we have placed the entire body of the loop inside the try block, despite the fact that it is only the call to next int that has the potential to throw the exception. We elected to do that for simplicity. We are free to include additional statements inside the try block as long as we include the code that can cause an exception. Let's scroll down to see the corresponding catch block. In the catch block, we designate the type of the exception that we wish to catch, which in this case is the input mismatch exception that will be thrown by next int when any characters that do not form an integer literal are entered. The way we know which exception will be thrown is by consulting the Java API. So let's look at the information it provides on the next int method of the scanner class. Notice that it specifies that input mismatch exception will be thrown when the next token does not match the integer regular expression. Returning to the catch block, the first statement inside that block will be executed is a call to next line. This call has the effect of what is sometimes referred to as flushing the input buffer. If, for example, several letters were entered, all would be removed so that each one did not generate a separate exception. Now let's run the program. Initially, let's enter a few valid entries. What you should notice is that the catch block is skipped. Next, we will enter an invalid entry to show that the catch is executed. Finally, let's enter a 0 to terminate the loop and see what will be displayed. We conclude this part of the video on exceptions by explaining the difference between checked and unchecked exceptions. Although Java copied most of the exception syntax from C++, the distinction between checked and unchecked exceptions is new. Checked exceptions are errors that can be recovered from. A file failing to open or improperly formatted input are examples of such errors. In contrast, unchecked exceptions are typically programming errors that can only be fixed by correcting a bug in the program. Attempting to access an array element outside its bounds or dereferencing a null pointer are examples of such errors. The way we can tell that an exception is unchecked is that it extends either runtime exception or error. Checked exceptions are subclasses of exception that are not subclasses of runtime exception. What we need to know as programmers is that checked exceptions must either be caught or declared as thrown. Failing to do so will generate a compilation error. We will see in Part 2 how we can declare an exception as thrown.